A matrix is a rectangular array of terms which is filled up of elements. And we label our matrix by rows and by columns. For example, if I let this matrix be called B, then B equals, and when we would label this, we would have rows along the side and columns up top. So each element here is in row 1, row 2, and row 3. So then if I wanted to look at it in terms of columns, this is column 1, column 2, column 3. So let matrix B equal, and I'm just going to plug in random numbers here. Okay, so this is matrix B. And if each of these numbers represents an element, so there are 9 elements in this matrix. So elements are also labeled by their position, and their positions are in terms of rows and columns. And we always do rows first. Rows by columns is how we say it. So if I asked you for the position of the number 10, this would be row 1, column 1, so we would represent that as position B11. And the 1, 1 is lower, like it's a subscript. So then if I wanted to know the element position of 60, this is row 2, column 3, so this would be B2, 3. And that's the position. So then if I said, okay, what is the value at position B, 3, 2, you would go to the third row and the second column, and their overlap is 80. So 80 is at the position B, 3, 2. Here are some other examples of what matrices could look like in terms of their dimensions. So this first one, we have 3 rows and 2 columns, so we would call this a 3 by 2 matrix. The second one has 2 rows, 2 columns, so we would call this a 2 by 2 matrix. And the last one has 2 rows and 1 column, so this would be a 2 by 1 matrix. So again, remember that rows come first and columns come second. When you add or subtract matrices, they have to have equal dimensions, or else you cannot add them. So let's look at an example. Since both of these matrices are a 2 by 2, then we can add them together, and the result is going to be another 2 by 2. So to break it down first, what you would do is you would add corresponding positions. So you'd have 1 plus 7, 2 minus 3, because it's 2 plus negative 3, 3 plus 0, and 5 plus 1. So this means your final matrix, the sum, would be 8, negative 1, 3, and 6. You follow the same process and rules with subtraction. These are both a 3 by 1 matrix, so we can subtract them. So we would do 1 minus 10 to get negative 9, 4 minus 3 to get 1, and 9 minus 2 to get 7. So remember, both matrices have to have the same dimension. This is a 2 by 2, and this is a 2 by 1, which means they don't have corresponding element positions, so we cannot add them together. You can also do scalar multiplication with matrices. For example, I can take any matrix, let's say we have 7, 9, 8, 1, 2, 4. I can take this whole thing and I can do scalar multiplication, meaning I'm going to make the whole thing 2 times bigger. And again, every element just gets multiplied by 2. So your final solution, your product, would be 14, 18, 16, 2, 4, and 8. You can also have scalar multiplication with a negative, with a fraction, and you would do the same thing. You would multiply the whole thing by whatever the scalar factor on the outside is. And we can also combine scalar multiplication and addition and subtraction. So with scalar multiplication, you don't have to have same dimensions because you're only taking one matrix and making it, whatever times bigger or smaller. But notice then how I'm also asking you to add them. And since they're both 2 by 2s, we can do this. So the first step in this would be multiplying the first matrix by 1/2. So we would get 3, 1, 2, and 5. And then we would add this to 9, -1, 3, and 2. So just like solving equations and combining like terms, we need to follow PEMDAS. So we would multiply first, and then we would add second. And our final solution would be 12, 1, 4, 7. We can also use the fact that if 2 matrices are equal and each element isn't given by just a number, notice how we have variables, since we know that they're equal, then each element position is also equal. So, if we need to solve for x, we know that x plus 1 equals x plus 9. So all we need to do is solve for x. I'm actually going to adjust this a little bit. I'm going to make it 2x right there, so that we have 2x plus 1. So if I were to subtract x from both sides, I'd have x plus 1 equals 9. Subtract 1 from both sides, x equals 8. Then we also know that 2y equals 4. So we just divide both sides by 2, and y equals 2. So in a problem like this, I would ask you to, given the fact that these 2 matrices are equal, solve for the variables. Okay, so I want you to remember first that when we identify a matrix and the dimension, we do rows by columns. I also want you to remember that we can, that you need to be able to identify the elements of a matrix and their position. You have to remember that when we add and subtract matrices, they need to have equal dimensions to do so. Remember, when we do scalar multiplication, all you do is each element gets multiplied by the scalar multiplier on the outside. And then remember that we can solve for variables given the information that the matrices are equal.